Welcome back, students, and very exciting. Today we're starting a new module, and it's a module about fractions, and fractions are centrally important to mathematics. I know, and we know that you've studied some fractions before, but we also suspect some of you might not have a really good kind of grasp of the fractions that you've done so far. So we are going to kind of start out almost from scratch. And the first question I want to ask you, and you may think it's a bit of a strange question for us to be asking, but it's this question over here. Which would you prefer? How many slices of pizza would you like? Now, obviously, you might say, well, I want lots of slices. But would you like 2/3 of the pizza? In other words, if we cut it into 3 pieces, would you like 2 slices? Or if we were to cut it into more pieces, let's say we cut it into 5 pieces. All right, there we go, 5 pieces. Would you rather have 3 of these pieces when there are 5 pieces, or would you rather have 2 of these pieces when there are just 3 pieces? Now, on the face of it, you might say, well, three is more. I'd rather have 3 slices. But remember that the slices are smaller. During the course of this section, we are going to learn how to answer this question exactly. All right, so this maths has got real relevance for your everyday life, because I suspect, like me, you really enjoy your pizza. Okay, so we're diving straight in, and we are on page 72 of your workbook. And the very first thing we're going to do is ask you to do an exercise whereby we're going to ask you to shade in the same proportion of each of these shapes, okay? So in this case, if we have a look at what's been shaded here, 1 square, 1 rectangle out of 4. So we want you to write that. Number of shaded out of the total number, 1 out of 4. Now, next door, we want you to work out how many would you shade if there were 8 and you wanted to shade the same amount. And we've made this really quite straightforward in the first instance, because I think you can see that to shade the same amount, we're going to need to shade both of these 2. All right, and that would be 2 out of 8. We're going to ask you to pause the video, and then we're going to ask you to try the remaining 2. All right. Now, one way of thinking about this, you might think of this. Suppose this was a cake. All right, everyone likes cake, and we were sharing this cake with 3 friends, so 4 of you all together. Your share would be that much. All right, now if the cake was cut into this many pieces or this many pieces, how many pieces would you get if you were sharing it with your 3 friends? So 4 of you all together. In other words, what does a quarter of the cake look like in terms of number of pieces here, where we've actually got 24 pieces? And in this cake, we've actually got 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. 4 eighths are 32. In this cake, we've got 32 pieces. We're going to ask you to pause the video, and we're going to ask you just to try and shade in those bits. When you've done so, let it play again. Okay, so if we've got 24 bits of cake, one way of answering this question is you could say, well, I'm going to take a piece, and then I'm going to give my friends a piece. 1, 2, 3 friends. And then in this column here, I'm going to take a piece, and I'm going to give my friends a piece. I'm going to take a piece, and I'm going to give my friends a piece. I'm going to take a piece, I'm going to give my friends a piece. I'm going to take a piece, and I'm going to give each of my 3 friends a piece. And I'm going to take a little piece, and I'm going to give each of my 3 friends a piece. This number is 6 out of 24. Now, you might be saying, Paul, I shaded 6, all right, but I didn't shade those 6. Aye, coin kinga. Okay, not a problem. But 6 out of 24 is important. All right, let's look at the 32. All right, well, if we look at this is 2 blocks, that's 2 blocks, and that's 2 blocks, and the last one's 2 blocks. So in fact, if we take 2 out of the 8 blocks going across, we will in fact be taking 8 out of 32 bits of cake. All of those are equivalent fractions. They are all the same fraction of the cake. Whether you have whether you have 1 piece out of 4, or 2 out of 8, or 6 out of 24, or 8 out of 32, that's how much cake you've had. Now, the last thing we want you to do is we want you to mark on the number line where that number is. All of these numbers represent the same number. They represent 1/4. So we want you to mark it like that. Okay, now we're going to ask you to pause and try the next one. Now, in the next one, we've now got a round cake, okay? And it's been shared. When it's cut into 1, 2, 3, 4, 5, 6 pieces, each person is getting 3 pieces. So now I want you to think of sharing the cake, and you're just sharing it with one other person, yourself and a friend. Umngani wakho. All right. And so count how many bits that your friend would get and how many bits you would get. Here there's 2 pieces of cake. Remember, at the bottom we are putting the total number of pieces of cake. Here there are 8 pieces of cake. And here there are just 4 pieces of cake. Right. Pause the video, try this one, and then we will have a look at how you went. Okay, so obviously, if there's 1 piece of cake, if there's 2 pieces of cake, just 1 out of 2. It doesn't matter whether you shaded the top or the bottom. All right, here we're going to, how many must we shade out of 8? If there are 8 pieces of cake and you're going to get half of them, well, we're going to shade 4 of them. And notice here, I'm saying I'll have that piece, thanks, I'll have that piece, or this piece over here, and maybe I'll have this piece over here. All right, it doesn't matter which 4 you shade, as long as you shade 4. Having 4 pieces out of 8 in a cake is exactly the same as having 3 pieces out of 6 or 1 piece out of 2. And if there's only 4 pieces, well, maybe you want to have 2 pieces. Maybe you want to have that one and that one. Doesn't matter which 2, but 2 out of 4. All right. All of these numbers represent a half. All right. Okay. Now, I think you understand how this is working. So we're going to ask you to pause, and we're going to ask you to try examples 3, 4, and 5. By all means, chat with a friend, all right? Chat with the person next to you, see how you go, and then let the video run again and see whether you got it right. This stuff is fundamental to understanding fractions, all right? What we are creating here is we are creating equivalent fractions. Okay, let's take a look at this one. Now, this here is 3 out of 4. So we need to shade the same fraction, all right? Now, in this one over here, we can just see from the shape here that we obviously need to shade all of these. That'll give us the same. Right, but how many are we shading? We're shading, in fact, 9 out of 12. And here, we are shading, if we shade up to the same level, because all these squares are the same size, we're actually shading 1, 2, 3, 4, 5, 6, 7, 8, 12 out of 16. And here we are shading, right, if we shade up to that level again, we're shading all of these, and I'm not shading them very nicely just to save time. All right, we've got 1, 2, 3, 4, 5, 6, 7. We've actually got 28, and we've shaded 3 rows of 7, 21 out of 28. All of these, out of 28. All of these fractions are actually equivalent. Okay, 21 out of 28, and they are all, in fact, equal to 3/4. There it is, on the number line. Okay, in this next one, we've got 3 out of 4, 5, 6, 7, 8. So I think we've got 1, 2, 3, 4, 5, 6. We've got 9 slices. We've got 3 out of 9. All right, now 3 out of 9 is actually going to be exactly the same as 1 out of 3. Now you might be saying, Paul, then how do we know there are 3 here? All right, but if we were to do that, then we've got 3. So 1 out of 3. All right. Looking at the picture here, it looks like we should shade. Remember, we're shading 1 out of every 3. So if I shade that one, I must leave the other 2, and I must shade another one and leave the other 2. So shading 1 out of 3 is exactly the same fraction as shading 2 out of 6. We hope this is making sense. Here, let's count how many pieces there are. 1, 2, 3, 4, 5, 6. There are actually 12 pieces. Right. So watch what I'm going to do. I want to shade 1 out of every 3. I want to shade 1 and leave 2 blank. Shade 1, leave blank, leave 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 blank. So 1, 2, 3, 4 out of 12. Doesn't matter if you don't shade those 4. So I realize that that's been off the screen the whole time, sorry. So 4 out of 12. Now we need to work out where are we going to put this fraction. Okay, and this one's a little bit more difficult because what we've got here, we've got the things divided into 4, and then each piece is divided into 6. So these little marks each represent a 24th. Now, if we had 24 slices of cake, how many would we shade? All right, to have the same relationship here. And maybe the easiest place to see, if we go from 12 slices of cake to 24, we've doubled the number of slices of cake. So we must double the number that we must shade. We are actually looking for 8 out of 24. 8 out of 24, 1, 2, 3, 4, 5, 6. 6 out of 24 is the same as a quarter. 7, 8. 8 out of 24. Here is the number that we're talking about. This fraction over here represents 1/3. It's exactly 1/3 of the length of the line. In other words, this piece over here is exactly the same length if I took another 8. All right, so there are 4, 5, 6, 7, 8. And it's exactly the same length as if I took another 8. 1, 2, 3, 4, 5, 6, 7, 8. The blue line, the green line, and the yellow line are all exactly the same length. Does it make sense? It always makes sense. All right, now let's do this last one. This time, in this shape, we've got 1, 2, 3, 4. We've got 8, we've got 12, and 8 of them are shaded. 8 out of 12. Right. Looking at this diagram, it looks like we would need to shade that there. Now, that there is 2 out of 3. If there are 6 pieces, all right, and I want to shade 2 in every 3, have a look at this. I'm going to shade this one, all right, and I'm going to shade, so out of the 3 on the bottom row here, 1, 2, 3, I'm shading 2 of them. On the top row, I'm going to do the same. 1, 2 of them. 2 out of 3 is exactly the same as 4 out of 6. Again, I'm going to take it to a real life example. If this was a cake, and this was a cake, and you were going to get 2 pieces out of 3, all right, that would be the same as getting 4 pieces out of 6. How many pieces have we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 on each row. 2 rows, we've got 18 pieces. Now, 2 out of every 3. So, have a look. When there's 3, of those first 3, I'm going to have 2 and then I'm going to leave 1 for my friend. Have 2, leave 1. Have 2, leave 1. Right. On the bottom, we're going to do exactly the same. Have 2, leave 1. Have 2, leave 1. And have 2, leave 1. And what have we got? We've got 12 out of 18. All of those fractions are equivalent. Okay. Now, where are we going to put the mark here? Again, remember that this is divided into 24ths. How many 24ths is the same as 8 12ths? Let's ask ourselves, what have we done? We've doubled the number of pieces of cake. So if we double the number of pieces of cake, then we must double our share of the cake. We must double the 8 and we get 16. All right, remember that there's 6 here. That's 12, 13, 14, 15, 16. And this place over here is 2/3. All right. You'll notice that it's actually exactly the same place as on the number line above here. Right. That's 1/3, 2/3. Okay. We're going to stop there. No, we're not. Sorry. We're going to do one more question. And now we've got a cake which we're going to share with 3 friends. So four of you all together. Okay. What we want you to do is just work out how many pieces, if these are different cakes and you're sharing them with 3 friends, how many pieces you'll get in each of the cakes. Okay. So we'll just do the first one for you here. Suppose you decide these 4 pieces are all exactly the same. You're going to have that piece in the middle there, and you're going to leave the other 3 for your 3 friends. So that's 1 out of 4. All right. How many pieces will you get of this cake if you're sharing it with 3 friends, and of this cake if you're sharing it with 3 friends? Okay. Pause the video very quickly. Try that and then have a look. Okay, so here, maybe you're not sure, but altogether there's 1, 2, 3, 4, 5, 6, there's 12 pieces here. Suppose you say, well, I'm going to have a piece, and then I'm going to leave a piece for my 3 friends. So leave, leave, leave. And then I'm going to have another piece. And then I'm going to leave a piece for my 3 friends. Leave, leave, leave. Then I'm going to have another piece. And then I'm going to leave a piece for my 3 friends. 1, 2, 3. I'm going to end up with 3 of the 12 pieces. 3 out of 12 is exactly the same as 1 out of 4. In this last one, we've actually got 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 36 pieces. All right, now let's have a look. Let's see if we can work out what we need to do here. What have we done to this number here to get from 12 to 36? And this is where it's so important to be good with numbers, all right? We've times by 3. Now, if we times that by 3, we must also times the number of pieces we're going to get. There are 3 times more pieces of cake. We must get 3 times more pieces. 3 times by 3, 9. All right, and so we in fact want to shade the bottom row here has got 9 pieces in, and I think you can now see that it makes perfect sense because I've got one whole row and my 3 friends. Let's say this, the one friend gets these pieces over here, the next friend gets these pieces over here, and the last friend gets these pieces over here, and we've each got 9 pieces. All right. The next question says, do your pieces need to be next to one another? And no, they don't. They don't need to be next to one another. All that matters is that we have the right number. How many? All that matters is how many we have. Okay, we're going to stop there. All right, and we'll look forward to seeing you next time. Have a great day. Nibe nosuku oluhle.